Excellent. Okay. All right. So what's Storm Injector? Basically, it is a preprocessor and a post-processor that deals with Australian lumped hydrologic models. So it is a common interface for generating ARNR 2016 as well as 1987 storm information, design storm information, and then it can run a whole bunch of different Australian hydrologic models in the background and then analyze all the results. So in this slide, it's the green areas are handled by Storm Injector. So it's basically an alternative to using the ARNR 2016 interfaces that are in the individual softwares, and gives you a consistent way with a bit more detail and a bit more advanced options than the individual softwares may offer. And just to show where it fits into a hydrologic modelling workflow, I've got 4 steps here. Firstly, building a hydrologic model. You can use the individual softwares for that, or you can use some GIS tools like Catchment Sim or MyRaw. Calibrating your model using historical rain events. Again, we've got tools like Catchment Sim's Rainfall Analyzer, other GIS tools, or the individual software packages to do that. And then we get to a place where Storm Injector can help, and that's doing the design storms through the model, coming up with flows and hydrographs for individual AEPs, loss rate sensitivity, and preparing hydrographs or rainfall information for hydraulic modelling. And Storm Injector includes some analysis tools to help you determine which temporal patterns you might need to run through your hydraulic model, so you don't have to run them all, which can be prohibitively time consuming, given there can be hundreds, if not thousands, to consider. So I thought for newcomers, we might just get straight into it and do a very simple example. So let's load up Storm Injector here. Basically, Storm Injector is pretty, hopefully simple. The important buttons are labelled with numbers and the order that you might apply them. First one is import model. Then we can get our data hub information. We can download our IFD information. Then we can generate storms and prepare model runs. So the first thing I'm going to do is import a model. In this example, I'm using a WBNM model. If you wanted to do this on your computers, this WBNM model is included with the Storm Injector download. It's called Sorrel Creek. Either of these ones should work. We just import it, and then it'll import all the subcatchment information. Now, Storm Injector is asking us if we'd like to calculate latitude and longitude for each subcatchment. Now, we can see here that the X and Y coordinates that have been imported they look like real world coordinates. In fact, they are MGA zone 55. So if we click yes and scroll down to MGA 94, zone 55, then Storm Injector will calculate our longitude and latitude for each individual subcatchment. It will also, in these top boxes, determine the average of all the subcatchment centroids. So that'll help when we want to download data from a website. So the next step is to get the ARNR data hub information with button number 2. When you click that, you'll see that it will load the data feed in the background, including all your temporal patterns, etc. When you hit Ingest Data, you should see that this information is then populated into a lot of the panels on the left-hand side of the page. You can see here we've got the point temporal patterns for the appropriate region. We've got our metadata, including our initial and continuing losses. We've got pre-burst depths, pre-burst ratios, climate change factors. That's all been downloaded automatically from the web. The next data we want to download is IFD information. Now we can name what this stage is called. We can just call it the center, for example. Then we hit button number 3, and it will connect with the Bureau of Meteorology website, and you can see the normal sort of website that you get here, including all the durations. Once that's finished loading, we'll be able to ingest that information into Storm Injector 2. Click Ingest Data, and now you can see that we've got this IFD location center, and we've got all the APs and duration information that was on that web page automatically loaded in there. For this example, we're just going to use one IFD location, but you can have as many as you want, and Storm Injector will automatically assign them to their closest subcatchments and do spatial distributions and so on. But at this point, we're ready for button number 4, which is behind the videos. I'll just move those. So we can select an event in this selected events panel. For example, if we wanted to do the 1% AP, we can simply click that and hit create storms. Once we do that, you can see that a lot of information has been populated on the right-hand side of this form, including the error reduction factors, which are based on the area, which has been automatically calculated based on the project file we imported. We can see also the AR 1987 reduction factors here. A good point, whenever anything's in red in Storm Injector, it means there's some sort of warning or note that you can be aware of that you can access by hovering the cursor over. This is just telling us that it's outside the limits of interpolation, and it's applying the 30-minute or 3-hour value. The next panel is the burst losses. Now, we'll look at the settings a bit later, and you can see where this is set, but the basic and default mechanism for that is the global initial loss minus the median pre-burst. So, for example, for the 1 hour 1% AP, it's 22.7 millimeters, which you can calculate based on the continuing loss of 27 minus the 1 hour pre-burst of 4.3. There's a panel here called routing increments, which is what time step we're going to run the hydrologic model at. Now, this can be very important for some models, such as XP rafts, and not important or not used for other models. But for rafts, I recommend using a routing increment of 1 minute, and then you can test high ones for some of the longer durations if you want to. In this bottom panel, we can see that Storm Injector wants to create 240 storms to cater for every AP duration combination. You can click on these rows, and it will highlight in yellow where it's getting the information from. You can see here that it's using that Temporal paddle 6777. It's getting its rainfall depth from this 4.5 hour 1% depth. You can see also where it's getting its ARF from, and its storm burst loss as well. So that helps you correlate where it's getting all the information. But each storm has a variety of columns here with information such as the duration, the temporal pattern, the classification, average rainfall depths, number of increments, and so on. Again, there's comments here if it's interpolating burst losses between durations and things like that. The next step is to create these 240 models. For that, we can use button 5. We again select our WBNM model, and this is where Storm Injector gets its name from. It basically takes that WBM model, strips out any rainfall information, and injects the rainfall associated with that row in the table. So after we do that, we'll see that we're switched to the Model Runs tab, and we've got 240 rows, and each of those correspond to a WBNM file that's been created by Storm Injector. If you look in the directory near your project, you'll find that it's created a folder called WBNM files, and you can see all these 240 WBN files associated there. The next step is to run them. We can click button number 6, Run Models. And Storm Injector is now running these 240 models in the background. You can see that they're currently hidden, but if you want to look at them, you can click Normal. It's pretty hard to read, but you can see that it's running all those models in the background. and it's simply a matter of waiting for that to finish. A Storm Injector can run multiple models simultaneously, which makes it a bit faster, and you can increase or decrease this simultaneous runs setting based on how powerful how many cores your computer has. Once it's finished, we can hit process results, and Storm Injector will open up the output files. You can see in the same directory now we've got output files for all those models. Storm Injector will analyze them all, pull out all the peaks, and aggregate and analyze some results in this panel here. So you can see it's showing here the critical duration results for every subcatchment. You can see tailor that in this form. So if we just wanted to show the 9-hour results, for example, and click that, and we'll show for each subcatchment what the average flow, median flow, the standard deviation, the flow corresponding to the adopted temporal pattern, what the adopted temporal pattern is, the ARF error we might come back to a little bit later, and at the end you can see all the flows for all the temporal patterns in ascending order and their temporal pattern IDs as well. We can visualize this with box and whisker charts. Here's one for the defaults to subcatchment 17, which has the largest area. And it's identified the 9-hour as being the critical duration based on having the highest mean flow for this subcatchment. And this is peak flow. But recent versions of Storm Injector have a few options here. We can also chart volumes. We can chart time to peak. And we can also do something called peak volume over a certain time. If we do this sort of for 3 hours, for example, it basically goes and analyzes all those hydrographs and determines the largest volume that flowed during a 3-hour period. So we are still doing research on this, but we're hopeful that this may give a better indication of critical or temporal patterns for catchments that are volume dependent. So we're still doing some work on that, and we would look forward to your feedback on that as well. All right, so that's a simple example of how quick and easy Storm Injector can be. There's only seven steps, but there's a lot of more complex things that we can do, and I'll go through some of them now. Mentioned before that we can do, before I get to that, actually, we might give you an example of a different IFD data set. So here we've downloaded the normal IFDs for ARNR 2016, but there's also very frequent and rare IFDs that we can download, and there's also ARNR 1987 IFDs that we can download. Now, you'll notice a lot of the Storm Injector buttons have these drop arrows which give you access to more complex features. So for example, if we wanted to download other IFD types for all ARNR 2016 IFD locations, we can use this option here. So say you had 4 IFD locations that you downloaded in AR 2016 and you wanted to grab all of the ARNR 1987 versions of that, you could do that with one click just by doing this. In our case, we've only got one gauge, so it will just fetch one. But you can see it's pulling up the old ARNR 87 data there, and it's already ingested all that. So now you'll be able to see here that we have center, and then we have another version called center ARNR 87, which has the ARNR 987 depths. You can also chart these, compare them, so they're quite similar. ARNR 87's a little bit deeper. Once we have the IFD data, we can also then run that storm. So we could pick, for example, the 100-year zone 1 ARNR 987. And if we hit create storms again, we go down to the bottom, we'll see we've still got all those ARNR 2016 storms, but at the bottom we've got all the ARNR 1987 storms here. If we prepare the model runs again, it'll take us back to this tab, and we've got all those storms again, and the ARNR 987 ones. Again, there's no reason to rerun the 2016 Storm because those output files are all still there and we haven't changed any of our data sets. So you can just right click and select all for this event, run all selected. So now we're just running those ARNR 987 events. If we then click read process results again, it'll read all the ARNR 2016 ones again, plus the new ARNR 87 ones. And now you can see that we have 2 events in our results that we can compare. There we go. So we can switch between events. Now, for some reason, in this example, ARNR 987 has a much longer critical duration and a much higher flow. We can compare the 2 events with this compare events option. This is showing critical durations, but if we wanted to compare just the 9-hour, we could switch the duration there. So ARNR 87 is giving us quite a higher flows in this example. We can also compare the hydrographs. If we want to compare events, we can use this second option again. And we can see the 2 critical duration hydrographs there. Again, if we just wanted to do the same duration, we can see that even for the same duration, the adopted temporal pattern for the ARNR 2016 options is quite a lot lower than ARNR 987. Now we could do similar events for downloading frequent and rare IFDs, but I won't go through that just to save time, but you can use these radio buttons here to switch between those events. Now, one thing to look out for here is if you go to very frequent, for example, and select an event here and hit create storms, it will remove the IFD, the non-frequent version, because you haven't got that option selected. But you can use, if you want to add to it, you can use the add to existing list. So that option will keep all the storms you've already got and then add new ones. So that's a clever trick for creating multiple events that might be in the rare, very frequent, and IFD categories and visualizing them all at once. You can also tailor the durations that you want to model to reduce the time and the data produced by Storm Injector if you know a rough duration range that you're interested in. The other thing to work out here, to point out, is we just used one IFD location here before, but you can see a spatial representation of your subcatchments here. And if you wanted to do a spatially distributed analysis, you might say, okay, we want a gauge near subcatchment 3 and a gauge near subcatchment 8. What you can do is you can select those rows using the control key. Again, go to the advanced options on Get IFD Data and say download ARNR 2016 for selected rows. You can see here that it's now downloading 2 IFD locations. In addition to the center location that we already have. And you can see in the background here that it's adding these new IFD locations to the rainfall depths panel. And then a trick here is that you won't automatically assign them. You need to use this option here, assign closest IFD locations for subcatchments using latitude and longitude. And once you do that, you can see that the IFD locations that are being used for each subcatchment are changing. And you can see this also in the spatial display, that the orange subcatchments are being assigned the rainfall from sub 03. The red ones are being assigned the rainfall IFDs from sub 08. And the blue ones are retaining that center one that we got earlier. Now, if you, I'll just turn ARNR 87 off and want for now, change this back to here. If we create storms again, the only difference you'll see is in this gauge, now you've got 3 IFD locations separated by commas here, and your IFD depths, you'll have 3 different depths, and you'll have 3 different entries in all your rainfall related columns. They correlate to each IFD location. And when you go ahead and prepare these files, you'll actually see that it assigns different rainfall depths to the different subcatchments, and that works for all the rainfall runoff models. I'll just go quickly to the settings tab and show you a few things of interest here. This selection of adopted temporal pattern is quite important. If you want to change the way it selects the adopted temporal pattern for a given duration, the options here are the first temporal pattern exceeding the median flow, or the first exceeding the mean flow, or the closest to the mean with a bias to those above the mean. So if you put a value of 2 in here, for example, then a flow would have to be twice as close to the mean below the mean than above the mean before it would be selected. So that's designed to give preference to those values that are above the mean when selecting the adopted temporal pattern. There's quite a lot of options also in initial and continuing loss years where you can decide what pre-burst adjustment method you mean. The default, I guess, is the global initial loss minus the median pre-burst. And you can choose whether you want to apply your reduction factors to your pre-burst. There doesn't seem to be a lot of clear advice in AR 2016 about that. There's some other methods from the literature here which you can experiment with. There's also an option here if you want to apply a reduction to the initial loss before applying your pre-burst because of an urban catchment, which is one of the recommendations in ANR 2016. You can override losses here as well. There's an option here for if there's a pre-burst excess. So if your pre-burst is more than the initial loss, what do? The default is to just use 0, but you can apply any excess pre-burst to the first time step of the model if you want to. So in areas where you have a lot of pre-burst, you can put the excess pre-burst over and above the initial loss as additional rainfall in your first time step. There is a very advanced option here called override global losses. And with an impervious threshold that you can set to whatever you like, say 20%. If you check that box, you'll see that there's a new window that opens up here, override global losses. Basically, what this allows you to do is set custom initial and continuing and impervious initial and impervious continuing losses for all different AEPs and all different subcatchments, if you like. So basically, these go in hierarchical order. So you can set for all ANR 2016 AEPs, all 1987 AEPs, or individual events. For example, if we put, for all subs here, if we put 20, 4, 1, 0, you'll see what that means when you hover over it. It means you're defining an impervious initial loss of 20 and a continuing loss of 4, and then impervious initial loss of 1 and an impervious continuing loss of 0 to all subcatchments. But you can then override that with values for subcatchments exceeding the impervious threshold that was in the settings, or individual subcatchments. So if you had one particular subcatchment that you wanted to assign different losses to, you could just enter its values, say for sub 5, and that would override what's in here. And if you put specific losses for specific AEPs, they would again override the losses that apply to all AEPs. So that's extremely fine-grained, granular control of losses, if you like. It allows you to do some very sophisticated things. I'll just turn that off for now, though. Other things in the results, particularly this temporal pattern analysis is quite interesting. That's used for determining which temporal patterns you might like to use in hydraulic modelling. For example, if we look at a particular duration, we can see here that there are 5 temporal patterns that have been adopted for the 17 subcatchments. 2 of them have been used 5 times, 2 of them 3, and 1 of them 1 time. So that can inform, what you might like to use in your modelling. But that's working on all 17 subcatchments. In reality, a lot of those subcatchments are probably not going to be like focus areas. So we can use this refined subcatchments option to identify the subcatchments we're interested in. We can right-click, clear all, and then just turn, say, 14, 15, 16, 17 on. And now we can see that only those results are shown, and also the temporal pattern analysis has been updated, and we can see that 6800 is being adopted most of the time. And we can also see here that subcatchment 14 has a high ARF error, so that probably means it's not a particularly good subcatchment to look at. If we turn that one off, we can see that this temporal pattern is actually the adopted temporal pattern in 100% of the cases. So we can use that to try and analyse which temporal patterns might be of hydraulic importance. Just to go back to that ARF error for a second, what that means, if you can hover over it, it'll tell you that subcatchment actually only has an area of 0.45 kilometres, a total upstream contributing area. So if you're actually interested in the results of that subcatchment, you really should be applying an ARF of 1 instead of the ARF which you used of 0.9352. So you may have a 6% underestimation of your rainfall in your model. So it's just like warning you that the results for that subcatchment may not be particularly valid. If you want to further investigate that, you can right-click and add this TP to compare. And what that does is put it up here. You can compare it to TP, and then in the results, if you go all the way to the right, oh, a bug. Okay, I won't do that. But what that's supposed to do is report the difference between, for all those subcatchments, it'll report the difference between that temporal pattern and the adopted temporal pattern. Now, I'll just show you a different project now to show some of the newer features that are in the latest version of Storm Injector. This project has a number of events modelled. We can see here that, I'll just chart these, we've got 60 events from the 63.2 all the way up to the 1 in 2000 event modelled here. You can see that Storm Injector has filled in this column here, which is tried to calculate the 1 in X years AEP. And that's, but if that's not correct, you can change in here. That's just for plotting purposes here. If you want, you can now plot based on a log scale with log AEP on the bottom. You can also log your y-axis and get your sort of more traditional log scale. And we also have the ability to show flood frequency information here, which you can import from something like Flight. Or if you just want to show some historical events on here, you can sort of add a row, and you could say that we had about a 150 year storm here, and we'll call it 1954 or something. And we had a flow of 1,000. And then if we check the include FFA information here and plot chart. We can click the label button as well, and you can show your historical events on there if you want. I'll just import an example data set from Flark as well. Where did I put that? Downloads. Yep, and this will import a range of historical events plus your confidence levels. So when you chart that, you can see your flood frequency analysis and how well or not in this case it matches. So that can help verify your historical events too. One thing we've also put into Storm Injector recently is the ability to save hydrographs. So at the moment, when you save a project file with the save button, it only saves all the tabular information. The hydrographs, when you chart them, are still read on the fly from the output files. So if you distribute a project file to someone else without distributing all the underlying data, they won't be able to see the hydrographs. But we now have an option in the save menu to save with all hydrographs, and it will go through and extract all those hydrographs and save them into the project file. Now that can take some time, and it adds a lot of adds some size to the data file, but it can be useful if you're distributing your results. And a good way to distribute results is with our new free Storm Injector viewer software. You can just load that up. This is free software. You can download it from the help website. It doesn't require any registration, and it's basically the same as Storm Injector, but you can see a lot of the buttons are grayed out. You can load up a project file. It just won't allow you to, change things or run models. It's basically just for viewing results, but it can do all the charting that are available in the normal version of Storm Injector. So instead of just sending some printouts, you can actually send a project file with hydrographs in it if you like, and your clients can actually view all the results for all the simulations and navigate them themselves without any need to own this or subscribe to the software. So that's something of use. The only thing I didn't go into before was custom events. We can't do that in the viewer. I'll just go back to this one. Custom events are useful for, there's some examples. If you right click on the custom events field, you can do rainfall increases, for example. Now I'll just show you this example. This would be an example of a rainfall increase using the 1% AEP 2016, ARMR 2016 temporal patterns, the rare classification, and a 20% increase. So if you click that, it puts the code in for you, but basically this is all you need to do. You can have multiple ones of these comma separated, and it will basically apply the normal RNR rainfall with a 20% increase. And you can also use $ to rename events. So if you want to call this 20 PC 100 or something to make it shorter, you can do that. That technique's also useful if you want to do non-standard events. Like I understand some Queensland users like to do the 39.5% AEP. So in that case, you could enter new IFD information in a particular column. Like say you overwrote the 1% information, then you could put a 0% rainfall increase custom event, which would basically just be a normal 1%, but since it's using your normal temporal patterns, it would, you might want to change this to the intermediate or frequent, but you can do that too, and then you can rename it the 39.5%. I know I've had to with $ before it, had to rush through that given time requirements, but if you want any more information on that, just just put it in the chat and we can get you the exact custom event code for that. So that's, I'll just load that project again, but that's basically the example on some of the advanced features I was hoping to go through with you. So I might just have a look in the chat window, and if there's any questions there, we can go through them. All right, I've just had a question here about the code for custom events. So I'll go through that in a little bit more detail. So let me just uncheck all these. Clear all. So, all right, if I just wanted to create 1% in these cases, like say we wanted to override our 63.2% event, you could export this to Excel or to a CSV, and then you could do a rainfall increase. I'll just start with this one, and you'd say 63.2% AEP, frequent, and we'd call it 39.5% AEP, dollar signs around it. And then if you create storms now, okay, the storms will go to the bottom. But now you can see that it's called the 39.5% AEP, and it's using the 63.2% IFDs. So if you were to replace these values with 39.5% IFD depths, then when you go through and do your charting, it'll all be labeled as this 39.5% AEP. So it'll make it quite easy for people to understand and reports and things like that. If anybody has something they'd like to, they think they'd work better asking using their microphone, and just put something in the chat and I can unmute you and you can address the group, or if there's any other questions, be happy to have them entered in the chat. Okay, modelling of PMP and intermediate extreme events. There is a example on our website of the PMP, which you can find. I think it's in our catchment sim help actually. Where is it? Here we go, under create integration and scripts. So just to go through this option here. Basically, if you have a catchment sim project with a number of subcatchments here, Catchment Sim has some tools to come up with the terrain category grids and position your ellipses. So, for example, it'll automatically position your ellipses, and then you can come up with, it'll automatically come up with the rainfall depths for all the ellipses. And then there's a script to export PMP information, and it asks you what state or territory, it asks you to select the duration limits, it asks you to select your terrain roughness grid and moisture adjustment factors, select your ellipse layer, and then it will automatically create the rainfall depths for all the relevant ellipses. And it will automatically create user variables for all the different PMP. This is for GSDM, all the different durations. And then it will create weighted average rainfall depths based on the spatial arrangement of all the subcatchments. It will create your calculation worksheet formats automatically in rich text file format. And it will also then create gauge files for all your durations. And then when you import your model into Storm Injector, you can use the option here, get IFD data, import IFDs from CSV, and you can import all those gauges into Storm Injector. You can assign them, so there'll be a gauge for every subcatchment to ensure the proper spatial distribution of the PMP rainfall. And then you can use a custom event, and you can see there's an example in here for PMF using GSDM temporal patterns. So the code in this case is custom, which means custom temporal pattern, and you can see the custom temporal patterns are in the settings tab. You can see them here, the temporal patterns for all the different durations. So this has got the GSDM ones automatically. The other proprietary PMP methods, you can, if you have access to those, you can import them from Excel and run them in Storm Injector. And then it's got the label, which correlates to the header in the IFD, then which what's that one mean again? Which initial loss method do you want to use? So if you want to use the initial losses for the 1%, you know, all the 1% pre-burst adjustments, etc. Which continuing loss you want to use? Do you want to use the data hub, or do you want to set a specific value? And then the next settings are whether you want to do any depth adjustments, whether you want to do a 20% increase or decrease. You have those factors there. Any initial loss adjustments. Do you want to apply an ARF, an error reduction factor, based on the area or not? And then this is what we're renaming it to. So that custom event, once you've got all the gauges imported properly, will allow you to run a spatially distributed PMP in Storm Injector. And there's some screenshots from there on the help site. And then you'll end up with all your durations. There won't be box and whisker plots because there's only a single event for each duration, but you'll get your curves, and you'll be able to establish your critical duration pretty easily. And you'll also have your PMF hydrographs in there as well. So it's a bit more involved. This example is based on using catchment sim, but there's no reason you couldn't just come up with a single PMF or PMP IFD data set and run it in Storm Injector without having to use catchment sim to do that. But this example just shows you how to do it all the way from placing the ellipses all the way to getting your flow information. Okay. I've had trouble importing, Oscar says, importing CSV files to override temporal patterns. I might have to chase you up with that one, Oscar. I'm not sure if you're doing those with the custom temporal patterns or in the point temporal patterns tab. But I can touch base with you on that afterwards. Is there a trial version we can use? There's a trial version on our website. You just go to our website and hit licensing, place an order, Storm Injector. It's a free trial here for 14 days. Add to cart and check out, and just ask you to register, put some information in there, and then it will send you a download link, and you'll be good to go. The trial is pretty much full featured except for exporting results, exporting CSVs and creating TS1 files for 2Flow and those sorts of things. What about taking an ensemble approach to PMF and interim extreme events by adopting 10 historical patterns? Yeah, I guess if you want to use your own historical temporal patterns, you could do that fairly simply with the custom temporal pattern options. You just give them a name and enter their duration time step, and then the individual increments. And then in your custom event, that you just call that group of temporal patterns with that second parameter there. So I think you should be able to do that fairly easily. The other thing I haven't mentioned today that a lot of people ask me about is one of the good things about Storm Injector is you can compare different scenarios. So say you wanted to compare a pre and post development scenario, provided you don't add extra subcatchments into your model, you can do that fairly easily. You just you can use this prefix option here to run the same event twice but with a different name. So if you put a prefix such as pre-dev here, and then you create storms, I'll just take this custom event out for now because that'll cause problems. You'll see that it has pre-dev at the start. Now, if you wanted to update your model to have higher imperviousness or different lags, you can then run it again with a post-dev scenario. And you could create an add to existing list or overwrite. And then you've got two events with the same parameters except with different names, and then you'd be able to use the compare tools in the charts to compare the results of those different scenarios, and you would be able to use those charts directly without having to do your own graphs and things in Excel. Storm Injector can't do or doesn't do Monte Carlo in Rawble herbs at the moment. It's designed around the ensemble approach. At the moment, Storm Injector, these models generate a lot of data, so we're not quite sure how to handle that yet with Monte Carlo. there any further questions? Otherwise, I don't want to take up too much more of your afternoon. All right, well, I hope you've got something out of this webinar. So first we've done, so please shoot me back an email if you have any feedback, or put something in the chat. I'd be interested in doing this again, or maybe having some smaller group sessions if people want to talk about doing some more advanced topics or some other features that you believe the software needs. So I'd be interested in your feedback. But I might draw it to a close, and hopefully you've got the tools you need to go out and do some interesting analysis with Storm Injector. Don't hesitate to get in touch with us if you're lost or getting a bug. It's still a relatively new